So I'm talking today about attacking modern SaaS companies. So just a quick thing on who I am. So I'm the CTO at Defense Storm. The only really important thing there is to know that we are a SaaS company, so I know all the things we forgot to do, build cloud software for quite a while. Last year at ShmooCon, I presented a kind of a cool attack on LastPass, which was a kind of phishing style attack, called LastPass. That was a lot of fun, and LastPass is still in the news with bad stuff, so if I can just say one thing, just maybe choose a different password manager. And last year at YurCon, I had a really fun talk called How to Implement Crypto Poorly, where I went out and found a bunch of terrible crypto implementations and laughed about it. But today I want to talk about software as a service. So there's lots of software as a service that you guys will probably know and use, Gmail, TurboTax, all this stuff. It's super popular, and it's definitely the new way that software is being made. It's a huge industry. It's over $100 billion now a year. So it's absolutely enormous. It's definitely the new way that software is being developed. And I really liked this tweet by Dino DeZovi that in 10 years there'll be only 3 major operating systems, and they'll be AWS, Google Compute Engine, and Azure, which is kind of like a weird thing to think about. But with Lambda and everything, you know, that's kind of interesting. What does that mean if there's only these 3 new operating systems? Like, we don't have rootkits for AWS yet. We don't have all of that kind of stuff yet. So what will that be? So my goal for this talk is to kind of explain how we make SaaS software, how do we do continuous delivery, why that's useful from a security perspective to know, what you should look for, what's typically done wrong. This is kind of a huge, broad topic though. So this is definitely an introduction where I'm going breadth over depth in any particular area. So I like to start my talks with a conclusion. So my conclusion is that if you have access to like the developer's laptop, the engineer's laptop, you probably have access to everything. If you have access to the build server, you probably have access to everything. The artifact server, the config management server, the NoSQL database, the container configuration, the cloud API, really, if you have access to anything, you probably have access to everything. And that's obviously a huge problem, and so as a defender, you have to try to make sure that this is not true, but as the attacker, you can take advantage of this. So I'd like to talk about why SaaS companies are different than your average Fortune 500 or other company. So SaaS companies have a fast iterative development process. They typically don't have long 6-month release cycles. They have tons of automation. It's very, very common for code that you write just to be pushed out to production very quickly. You have a lot of empowered engineers, which is great because engineers are able to just write code and do things and improve your product very quickly. You have a ton of brand new, very, very powerful tools that let you install packages on all 1,000 of your servers very quickly and easily. And there's also a lack of security culture. This is pretty common to many companies, but SaaS companies in particular seem to have a kind of a blind spot here. There are also weaknesses. So if we take the strengths, each one of these strengths kind of corresponds to a weakness. There are also linchpin servers. There's like the build server, all this stuff that is really, really critical. And if you get access to that, you get access to everything. There's not much security monitoring despite the automation. Collecting logs is pretty expensive. Splunk licenses are pretty expensive, so they actually tend not to do much security monitoring. They tend just to do very narrow things. Empowered engineers really means that there's no security planning or anything. Sometimes you talk to security engineers at SaaS companies and they're like, I didn't know my developers started up a Redis that was listening on a public IP address with no auth. Whoops, like we just didn't know. We just had no idea because the fast iterative development process just did not allow them to do anything there. The powerful tools means you can use them for evil. We'll talk a lot about that later. And the lack of security culture really means that there's little to no budget for security. So let's talk about how do SaaS companies work? How are these products made? So first, the engineer needs to write the code. This is probably from a spec or something, right? They need to code it up. They're going to commit it to some kind of version control, Git subversion, maybe on GitHub. Then continuous integration is going to build and run the unit tests. There's lots of different options for continuous integration. The most popular is Jenkins. Travis is used a lot in the open source community, and CircleCI and Shippable are kind of coming up. Then we're going to automatically deploy it to our development environment. From there, it's going to be promoted to staging, which is kind of like a test QA environment. Sometimes that's automatic based on some integration tests, and then you can deploy it to production where your actual customers are going to use it. Most companies, that's still a manual process, but really advanced companies like Facebook will have totally automated development processes. So you can commit code, and then a few hours later, it's actually in production without any humans clicking any buttons. Pretty cool. So let's just talk about just how does this aspect of the development process work. So continuous integration, Jenkins, probably most people are familiar with Jenkins. You can put projects in here, build whenever you commit the code. Very nice, it does build notifications, that kind of thing. So how does that work? First, the build is triggered, source code is downloaded, then it's compiled, the tests are run, the software is packaged, and it's uploaded to the artifact server. So here's an example of one way you can get in. So we want to run our attacking code on somebody's Jenkins. So we can backdoor everything it builds. This is kind of like a reflections on trusting trust kind of thing. If you can backdoor everything, you can run your code on all of their servers very quickly and easily. So one thing I knew is everyone can submit a pull request on public GitHub projects, right? Some people use Jenkins for their public GitHub projects to build and test. And I was wondering, if you just submit a pull request, does it just run code on their Jenkins? Because if you can run code on their Jenkins, you have access to their Jenkins, and now you can backdoor everything they run. So I found this tweet, which is really awesome. There are actually bots on GitHub that are creating pull requests just to mine Bitcoins. So all they do is they find projects that are running continuous integration, they insert Bitcoin mining code into the tests and submit them, and then as soon as they start running the tests, they're just mining Bitcoins. And obviously, eventually you have to find that. But so yes, the answer is absolutely yes. I found the GitHub pull request builder plugin, and what this does is it lets you hook up your GitHub to your Jenkins. But on this one, unfortunately, it makes you verify the patch, so the admins have to look at the patch and make sure it's not actually a Bitcoin miner. Fine. So I wanted to figure out a way around this. So I set it up. And so what happens is as soon as you make a pull request, the bot at the bottom says, can one of the admins verify this patch? So the admin has to log in and look and make sure it's not a Bitcoin miner. But I noticed it was 5 minutes apart, and 5 minutes sounds suspiciously like polling. If it was, webhook event driven, it would be very quick. So I said, okay, well, let's figure out how it works. So every 5 minutes, the GitHub pull request plugin is going to pull the pull request to see if there's any new pull requests. Find every open one, check to see if the author is whitelisted. We trust this author to not run Bitcoin miners, or the pull request is accepted. The admin says that this is not a Bitcoin miner. If not, post a comment asking. If so, build the pull request and run the tests. So this is how we're going to work around the GitHub pull request. We're going to post an innocuous pull request like, oh, I'm cleaning up the tests. Then the bot will say, can the admin verify? The admin user will look, say, hey, this looks great, I want to run the tests. Test this, please. Then within 5 minutes, we can force push a different commit that is a new malicious commit. And the reason why we're force pushing instead of just regular adding a commit is because if you just regular add a commit, you will send an email to everybody involved saying, hey, there's been a new commit, and whoops, you should recheck this. But if you force push, GitHub does not notify anybody. So then you are going to be running malicious code on their Jenkins. You can see I did this on GitHub, success, build, finished, and this was with my special pushed edition. So this is what I did. I just added a simple thing to the thing, which is hacked, and then in my Jenkins, you can see that this is building pull request, and here at the bottom it says hacked. So it was just very, very simple. This is pretty basic. And it's very easy to do this sort of thing. So if you ever find somebody running a Jenkins integration, it's always interesting if you can get on that Jenkins server. I did a quick Google search to see how many people are using this plugin. It looks like a lot, so potential pen test targets might be using this sort of plugin or something similar or something worse. So you don't have to use this plugin. You can just hook up pull requests and they have no auth mechanism whatsoever. So if you would get access to Jenkins, you can read, write any file Jenkins controls. So the credentials.xml, this has a ton of useful credentials, like it might have credentials for your artifact server, like upload. It might have chef or configuration credentials. The .m2 directory, if you use Maven and Java, this is where all the libraries live, so you might backdoor some libraries, change the jars around. Secrets is exactly what it sounds like. It's a bunch of secret keys, that kind of stuff. And the workspace, that's where all of the projects actually live. If you want to do a direct backdoor, like you want to put in some code that's modifying something to insert your own, like question mark, admin equals true, sort of backdoor in a web app or something. There's loads more you can do with attacking continuous integration. There's a really, really great talk by Jonathan Claudius called Attacking Cloud Services with Source Code. That's like highly recommend because he goes into a ton of cool little bits and pieces about what you can do and how to get at their continuous integration server from this app. So what happens to the build after we build it? So we're going to upload it to the artifact server. And this is the place where all the code is going to live. So it's basically just a fancy web server. It holds different versions of your software. So it holds version 1, version 2, version 3. Usually you can't delete them or overwrite them, which makes sense. You only have one version of these. So the continuous integration is going to upload to the server, and the deployment software is going to download. Some examples, these are the Java ones, Sonatype, Nexus, JFrog, Artifactory. These can be used with other languages, it's not just Java. Also, Docker registry counts as an artifact server, so if you're using Docker or something, these are all the same sort of type of server. So if you can upload to the artifact server, you can upload backdoor versions of code. So with just a simple curl command, if you have access to this, either you got this from the Jenkins, or you got it from a developer's machine, or you somehow got it from one of their other machines, you can just upload. It's just HTTP. It's very, very simple. And if you upload a new version of their code, when they download the code, it will be running whatever you want. Deployment. So how do you get the code from the artifact server onto all of your machines? There's mainly two ways nowadays. There's the Docker Core OS sort of thing, which is a virtualized OS, which is not the same as like VirtualBox VMware. It's the operating system itself is virtualized, and usually you have all of your dependencies included. So you have your database, all your libraries in one kind of Docker container. Usually your continuous integration will build the whole image, which is nice because then you can just pull it down from the artifact server directly. Configuration management software is also what a lot of people use to deploy things. Chef, Puppet, Ansible, Salt, CF Engine, there's tons of these out there. They configure nodes and they can also deploy software. And there's actually a lot of custom scripts out there. And these custom scripts might be bash scripts to say every 5 minutes, pull this S3 bucket, give me the versions of softwares, and then download them. People do whatever they want to get their software out of their nodes. So let's talk about containers first. So these are like all of the different tools I found on containers. There's Docker, there's Kubernetes, CoreOS, Mesos, KT, Panamax, Portainer, Rancher, Shipyard. There's just so many of these. I can't even keep track of them. It's just crazy. And there's even more. I was talking to my ops guy. He's like, you forgot these other 10 of them. And there's just so many. So as a pen tester, don't worry about knowing every single one. You should probably be familiar with Docker and Kubernetes, maybe CoreOS. Those are far and away the most popular ones. All these other ones you can probably just learn as you go. So there's some security trade-offs when you're using containers. One really great benefit is easy patching and updating. Because it's just a container, if there's a OpenSSL bug, all you need to do is build a new container, deploy it everywhere, and it's great. Fits microservices really well, which we'll talk about in a little bit. It's easy to automate building and deployment of these. There's tons and tons of great tools out there for building and automating Docker images. One important thing to know, both as a defender and as an attacker, containers are not security barriers. If you get root in the Docker container, you have root on the host. A lot of people don't know that. Definitely should. That is not part of the design. Because people are like, oh, I found this new Docker, exploit. It's not real. That's how it's designed. But the biggest danger with containers is that they're still so new that people don't know the security trade-offs yet. They don't know exactly what you can and can't do with this software. So let's talk about some examples of potential pitfalls or potential ways you could break through. So Kubernetes, what this does is it automates deployment of containers. So you have a bunch of containers, you want them deployed in your dev, staging, production environments, you want to orchestrate all of that. So you might have an SSH Bastion host that you say, well, you have to SSH into this machine first so I can put good logging on it, I can have good auditing of that, so all of my engineers, I know exactly when they logged in. But Kubernetes allows you to bypass SSH completely. And this kubectl exec gives you a shell on the pod called pod name. And this tunnels over 443, which is a little harder to firewall off than 22. And this isn't a security problem. It's just I've run into security people who didn't know this, and then they were like, "Oh, I don't let my engineers SSH into production," except they didn't know that they were running, essentially a SSH remote shell. And this is challenging to restrict, but it's very convenient for the engineers. And that's kind of one of the big themes you'll see with a lot of SaaS companies. Things that are convenient for engineers tend to be used. Things that are inconvenient, like security, tend not to be used. So our challenge is we need to make security easy to use. So this is from a great talk called Crash Course in Kubernetes and Security at Sector last year. And just like I was saying, like Docker is not a security barrier. So here's an example of how to get root, how to drop some ODAs. If you run Docker like this, so this first Docker run is basically just saying start a Docker container, and I want you to map this user's home directory to /hdocs, and then run the bash command, which is basically just copying bash to hdocs root shell, which is now mapped to our home directory, and then make sure it's set UID 4777. Then if you look on the host machine, this is still on the host machine, the root shell is owned by root and it's set UID. We're going to run the root shell and you'll root. So there is absolutely not a security barrier whatsoever. This is as designed. It will never change this. So this is totally fine. It's totally fine to use containers. It's just important to know if somebody gets root in your Docker container, they have root on your machine. So you need to design different security mitigations for stuff like that. Of course, people just put shit on the internet. This Portainer, this is a container management software. I typed Portainer into Shodan, and this is the first thing that came up. This is a bad sign if this is on the internet, because you have access to all of these machines. I can SSH into every single one of these. I can start up new ones. I can delete all of these. I tried finding the person this was and contacting them, but I couldn't figure it out. And there's tons of these. So you just search for all these like Docker sort of tools. They're all over Shodan. And this is obviously a huge problem for your security if your engineers accidentally let you do this. Here's another one that's Kubernetes. I actually found the Jenkins password on this one too, which is kind of next level awesome, because you can, not only do you have access to run anything, but I also have access to their Jenkins. So this is a bad sign. If this is happening to you, you're not doing so hot. Okay, let's talk about configuration management. So configuration management really solves this problem. So your software, your amazing SaaS software, depends on a few things. It depends on NTP running, and the time being correct, because maybe you use AWS. It depends on a recent kernel version, because maybe you're using something cool in Linux, so you need a new performance improvement. And let's say you depend on ImageMagick. Hopefully not, because of all the image tragic sort of things, but let's say this is what your software depends on. How do you make this happen? Are all 175 nodes in your fleet up to date? How do you make sure that their software is running? Like you're not running an old OpenSSL or something. Do they have all these packages installed? How do you peer review and approve changes? All of these problems are solved by configuration management. Even if you're using Docker, even if you're using all of these things, you still use configuration management to make sure that the Docker hosts are running the right version of Docker and all of that stuff. There's a few tools that do this. The tool that's, I think, the most popular, the tool that I use most is called Chef. So what this does is it kind of treats your infrastructure as code. So you describe what, not how. So how is basically all of programming. It's like imperative programming. And Chef lets you describe what. So for instance, in this example, you're just saying there is going to be a directory called op application config. It will be called, it's called this. It has owner service. It has this mode. Make sure you create it, and make sure you create all the directories it needs. And you can make really complicated objects, like this is an application object, and this is how you construct it. And what's cool about this is you don't need to worry about anything. It's idempotent. So because it's idempotent, you can run it 5 times. And as long as that directory is there and has these permissions of this owner, it will be set up. So people use this for installing app packages, making sure that their services are configured properly, all that kind of stuff. So the tool knife is what you use to interact with Chef. So it has a config file here. This tells you where the Chef server is, and you have the user.pem file, which is a private RSA key And so using these two things, if you get them from a developer's machine or from Jenkins or something like that, or even from the nodes themselves, you can now use knife to interact with Chef. What can you do? So you can list every node in the environment. One thing when you're pen testing is you might have a list of all the nodes, you might not. If you don't have a list of every node, knife node list will just tell you every single node that the Chef server talks to. You'll find the database master, all the stuff. Install packages for every machine. So just knife search a packages will tell you every single package that's installed. So you can find old versions of things, you can find out of date, you can find if they're all up to date, you need to take some other avenue. Kernel version, you can do kernel release, and this knife tool is just super, super powerful. It's built for like awesome sysadmin operations type, so every possible conceivable thing you want in here. One thing that I like is that some people store secrets in here too, so like if you just run knife search and L just lists out all of the different config, you can grep the word password, and maybe somebody put some passwords in there. But just looking through that whole command is super useful because there's a lot of interesting stuff in there. You can find even more data. Knife has this concept of data bags, and data bags are basically just like JSON blobs. And if you just do knife data bag list, you'll get a bunch of named data bags, like, oh, this is my SSL certificates. So if you do knife data bag show SSL certificates, now you get their SSL certs. You can encrypt data bags, and it's best practice to encrypt them. So if you come across encrypted data bags, you'll need to find the encryption key first. Usually those are on developer machines or on the Chef machines because they're all shared key encryption. You can run arbitrary SSH commands. This is like kind of the most powerful thing Knife does, and this is like the killer feature 5 or 6 years ago for Chef. You can just do knife SSH. The star means which machines to run it on, so star means everything. And you just run a command. The only problem with this is this will prompt for SSH off, and usually as the pen tester you don't necessarily have, you haven't like compromised the LDAP or installed your SSH key yet, so this is probably not going to be something that's super useful, but it's very useful for admins just to run quick commands, stuff like that. So if you want to backdoor everything Chef does, the first thing you need to do is you need to find the most commonly used recipe. So I did this, find old recipes, sort them, make sure they're unique, sort them by count. So it looks like Zeesh on this one is, let me go back, is the most common. Looks like sudo. So all these recipes are like make sure Zeesh is installed, make sure systat is installed, sudo, Slack handler, all that kind of stuff. So we can backdoor any of these, and it will probably run on every single node because every single node wants Zeesh. So what we're going to do is knife cookbook download. So the way Chef works is it has cookbooks, which are comprised of recipes. You get it, Chef, it's like kind of funny. And knife, right? So you download cookbooks, which are comprised of recipes. So we're going to download the cookbook, and we're going to put our backdoor into the Zeesh recipe. And then we're going to just upload the cookbook back. Very, very simple and easy. So the backdoor I made is just very simple. Bash backdoor, you just run this every time. Just wget some script that you've written and just execute it. You could make something that's much more Chef compatible, something that's like actually useful or something. But this is just how you do that, and then this will be run on every single node that has Zeesh installed, which is probably everything. So now you have access to all the things that had Zeesh. I also want to talk about microservices, because this is kind of one of the ways that SaaS companies are very different than a lot of traditional companies. So first, what are they? They're small services that do a few things. So they're usually centered around some kind of business area. So if you have like a photo website, you're probably going to have a photo uploader service, you might have a photo search service, and you might have a photo tagging service. You break them up. So like in my example, if you're making a to-do list part of your app, you have a to-do list service. And usually they communicate exclusively via API. There's no shared memory, there's no data structures. Maybe you'll communicate via database, but usually it's REST, HTTPS, and JSON. Also common is actually queues, so RabbitMQ, Amazon.SQS. And the analogy I like to make with microservices, because there's, Martin Fowler doesn't really like microservices anymore, is that microservices are like functions, and typically we want our functions to be small. Maybe not like 4-line, super small functions, but you typically don't want them to be 800, 900 line monsters. and instead you want them to be small and composable. Same thing with services. You don't want this is my company, it's in one project and it does all of the things, because then developers start doing funky things like, oh, I'll put this in memory and I'll share this, and you didn't realize that and it wasn't persistent. So microservices is a very quick, easy way to do development. So why do we use them? We use them for faster development time. It's much easier to understand, oh, this is just a photo search service. I don't have to worry about uploading and all that kind of stuff. I can just worry about search. It's a logical separation, very easily monitorable, which is nice. You can say, okay, well, it looks like our photo search isn't running as fast as we want it to, but the photo uploader is working great. And this is one of my favorite bits, especially as somebody who's running a service that needs to be up 24/7. The service can remain partially up during disruptions, so if the photo uploader doesn't work, that's fine, because the photo search still works, so at least part of your service is still going. It kind of gracefully degrades if it's designed well. And this is really important from a kind of uptime perspective. And it's very easy to test and release new things automatically, because if you only need to consider what happens with uploads, you don't need to consider, okay, well, I don't need to worry about if this is going to break the search, because it probably won't. It could if you design it poorly, but most microservices are much easier to test and reason about that way. So here's an example. So here's our user, and they're going to get, they want to use the to-do list application. So they're going to get the front end, which is either JS or React or something like that. They're going to download that HTML from some CDN or some web server somewhere. They're going to then log in. They're going to auth to the auth load balancer, which is then going to talk to the auth service, and which is then going to talk to the account database that's going to store username, password, email. Well, it shouldn't store the password hash. Then, once they're logged in, they're going to talk to the actual to-do service to create new to-do items and to mark them done. They're going to talk to, which then corresponds to the two to-do services. The to-do service needs to talk to the auth service to make sure that this person sending it is a valid user and it's logged in. Usually this is cookies or something, and said, hey, is this cookie still valid? Then they need to talk to the to-do database. They need to, add some new to-do. They might put something on a queue. I couldn't really think of something maybe like, it's some kind of like, in the future we need to do this. So it's some kind of batch processing. A lot of services have this. So you put it onto a queue, and then the batch processing is going to get to it whenever it gets to it, and then it writes to the database. So as the pen tester, you also want to ask, like, well, how is this service-to-service authenticated? Is that some kind of shared key? Exactly how is that done? Is there rate limiting on our load balancer? How do we do input validation? And also, my favorite is just not SQL injection up front. Everybody's very familiar with SQL injection, but SQL injection is usually tested like, oh, I'll add a new to-do item and I'll put a quote in the name or something. But if you can somehow get it so that it's actually in the back end of the system where it's not directly facing either from a queue or something, SQL injection is much more common the farther away from the testing surface you can get. So like way back there is a very interesting place to do testing. And really I like to draw a line on services. So everything to the left of the line is kind of like the outside world. And developers are actually pretty good at making that work, making sure that's not totally garbage from a security perspective. But once you get into the right side, that's where everything's like, oh, if you're on the network, you're trusted, and all that kind of stuff. Hard on the outside, squishy on the inside. Have you ever heard that analogy for like firewalls and everything? Absolutely true for SaaS companies. So if you're in that network over there, it's very unlikely that you can't get access to everything. Take a very, very well-designed SaaS network for that to be the case. So the API, if microservices communicate via the API, you need to figure out what the API is. And I'm assuming you don't have API documentation, because if you have API documentation, your life's a lot easier. So obviously you can use their app or Burp Suite or something to figure out the domain or to figure out paths and everything. So like for instance, you'll have auth.example.com or maybe the to-do list service.production.example.com, and you're going to have a bunch of these if they're not all handled behind one API. My favorite thing to do is to use the web application description language in Java specifically. There's a bunch of web application description languages. They're very useful from a developer perspective because you can load them up. They look like this. So this is the one produced by Jersey. So if you have something like this, so this is basically just an XML document describing what the API is supposed to do. So we can see this is on example.com, and we're starting at slash and the resource path to do /ID, and we have a method get on that, and that corresponds to the Java function called get to do item. And then it's going to return a response, which is application JSON. And obviously your application.waddle is going to be much longer and more interesting. And what I like to tell pen testers is that if you get this, usually it's not useful to test, like to fuzz or test outside of this. So, oh, I'll try /to do something else, I'll make something up. That doesn't normally work. You have to kind of stay within the bounds of this, because actually Jersey and Java are really good at making sure the input fits in this schema. But as soon as you get into schema, then that's where your developers are there and they've forgotten to handle the null case, or they've forgotten to do something like that. They forgot to, or they had a special ID with all zeros that does something different. That's very common because people like to kind of implement little backdoors for themselves. The place to get this is usually just /application.waddle. You can actually see this on some production services if you know where to look for it, which is /. And it's often there, and you get this very nice documentation. So then you can point your Herp suite or some API fuzzing if you want at it. It's very useful. So I want to talk about some more weaknesses of microservices from a security perspective. So like one of them is this kind of connection between services. So one thing that's always the problem with composable systems is complexity. So while each individual attribute is simple, like our search service is simple, once they start interacting together, it can get very complicated very quickly. And there's this one microservice system that I know of that is about booting up various other containers and everything, and actually it can get into this state. It's a kind of gossip protocol thing where it will talk to everybody that it knows. It's like, oh, I know these 10 people. I'll tell everybody it knows about the state that I have, right? And it's this kind of cool microservice architecture. But the problem is it actually has these, if it ever gets a problem, like where one node thinks that it's down itself, which is very odd and a bug, it can start having these harmonic like things where half the fleet starts to go down and the other half starts to come up, and it starts like coming up and down and up and down. Those things are very, very challenging to debug. So microservices are best when they're like designed very simply and they don't have a lot of complex interaction. A lot of CRUD, create, read, update, delete. That's like the kind of the key thing for a simple microservice. Service-to-service auth is a big thing that I, just speaking as a developer, I know a lot of people don't know. They either don't know or don't care to find out how to do service-to-service auth. So how does the photo search service talk to the tagging service? Because maybe it needs to know what tags that users are allowed to search on. How does it authenticate? How does the tag service know that the search service is allowed to do that? The most common is just network level auth. If you can talk to the service, you're allowed in. This is the hard on the outside, squishy on the inside idea. Shared key custom auth is kind of the next most common. So like if somebody just implements some HTTP header that's like X company auth, and they just set it to some string, or you set some shared secret that you do a little bit of encryption, hashing, HMAC sort of thing on. You do some kind of custom thing there. Usually it's the same key on every box. If you get that key, you can then do your service-to-service auth. And my favorite is actually pass-through credentials. So you're acting on behalf of the user. So if you talk to the search service, it was the user authenticated with that, and then the search service was like, well, I'm acting on behalf of this user. So that's how it's authenticated. That's very nice because it's very consistent from a security perspective. Every service has to authenticate. There's no special cases. There's a few other better ones, like the Spring Framework has a really nice service-to-service auth plugin, but I actually haven't seen many people using it. Okay, we need to talk about the cloud. So the cloud, what is it? Everybody knows what the cloud is at this point, so I don't need to talk about what it is. So access keys. So one of the best parts about the cloud is extremely, extremely fine-grained permissions. Like you can say, this user is allowed to upload to only this file on this bucket, right? Very, very fine-grained. Or this user is allowed to read but not write to this queue. Or this user is allowed to start instances, like EC2 instances, but they're not allowed to look at them. Or they're allowed to only shut them down. You can do very, very specific things. But of course, because we want things to be easy, sometimes operations teams or dev teams just make super wide permissions. Oh, I'm the CTO of the company, I should be able to do whatever I want. So they have permissions that let them do anything they want. And then obviously if you get access to their credentials, you have access to everything. So where their credentials live is usually, like for AWS, it's AWS credentials. Sometimes they're committed to source control and then reverted. So they're saying like, oh, well, whoops, I shouldn't do that. And the way you find AWS keys is just by looking through every git commit. So this just lists out every git commit hash, and then using XRs, we're just going to say, well, use git grep to find something that looks like an AWS key. And if you ever find anything like this, it's useful to just try out. The problem with AWS keys is you usually can't find out what they're for. You can just find out if it works or if it didn't. And the right thing to do is if you ever accidentally commit something to source control is you can revert it if you want. The thing you have to do is revoke that key. That's the first thing you have to do is revoke that key and make sure it's not going to be used anymore. One of the nice things about the cloud is there's a lot of good logs out there, because for every single API action, starting up an instance, creating a queue, putting a policy on a user, everything creates a log. So here we have a bunch of logs from AWS. So like Andrew did a stop instance on this instance, and then it looks like he started up that same instance later. And then Eric logged in twice. You can see all that kind of stuff. It's very useful. You put this in your SIM or something. This is kind of really obviously essential from a security perspective.
I just wanted to point out real quick, on your previous slide, you had a regex to grep for to find the AWS keys.
Yes.
There's actually 2 regexes that are posted by AWS that reliably find them, because if you notice, like yours starts with AK pattern. On your screenshot on the next slide, it starts with AS.
Yes.
So you wouldn't have found that key. But if you look on AWS, you can find the 2 patterns and it'll find them all.
Great. I just want to repeat that because that was really cool. So on AWS, they have 2 regexes that you're supposed to use instead of my one to find AWS keys. Awesome point. Thank you. Yeah, you can even see on my screen on the top left, it wouldn't find this AWS key. It's ASAIA instead of AK. I figured it was like a thing that was like AWS key. I was like, oh, that makes sense, and it kind of made sense internally in my head. Yes, great logs. I found this really great blog post that was talking about how to disrupt AWS logs. So I just want to talk about that, because if you're using this for kind of critical security function, you need to know if your attacker is stopping you from looking at the logs. The most obvious, loudest one is to just delete the CloudTrail thing. This is obviously going to generate more logs, and it's going to be kind of noisy and loud. But this will just stop CloudTrail from logging anything. And then you won't have any more logs, and you won't notice what the attacker's doing at this point. Kind of the next most, slightly quieter than that, is just saying stop the logging, right? Don't delete the whole trail, just stop. Maybe they're monitoring for deleting the trail, but not stopping logging. This is kind of a clever one. This is saying, okay, we'll only log in the region that the CloudTrail is running in, and not in every region. Usually CloudTrail logs globally into one place, which is very convenient. But if you update CloudTrail and say, actually, just log in US East 1, and then if you're using US West 2, you won't get any logs over there, which is kind of clever because it's still partially working. So if they have any monitors that are like, are anything's firing, that won't happen. You can also just delete the bucket if you have access to that. So if all your CloudTrail logs are going into the bucket, they'll just start silently failing because you won't have any logs anymore. If you log into the UI, you'll see it there. This is another kind of fun one, an S3 lifecycle rule to delete all the logs after 1 second. Hopefully you'll get, their log getter won't get in there before your S3 lifecycle rule just starts deleting all the logs after 1 second after they're written. And this is kind of the most clever one from the blog post, is you encrypt the logs with a key the company doesn't have. So you basically say, I want to set up the logs with this KMS encryption key, and then you just throw away the key, and then they don't have the key, and they're writing the logs, but nobody can get at them. This is the blog post I found from Disrupting AWS Logging by Daniel Grislak. Very, very fun. There's even more fun little things in there about disrupting logging. So I'd like to just talk the last few seconds about just the blue team and what kind of I've learned from running a SaaS company. You really do need to restrict developer access, even though like it's great having empowered engineers that can do everything. It's not great if they can just SSH into production and start running things and opening up ports and everything, because you have to ask, it's not just you that you are worried about, but it's like your new intern that has production access, or this new guy who you don't really know well. It's like, would you give everybody access to your house that you don't even know? Once you start getting a certain size of your SaaS team, you have to start being like, I don't know these people anymore. I can't necessarily trust every single developer. The best way to do this is just to automate everything. The wrong way to do this is to take away developer access and then not let them do anything, because then engineers get really mad. If you just automate everything, you have no excuse. And if you say, hey, you're not allowed into production, but instead write this awesome monitoring thing, engineers should really like that. Continuous integration, despite the thing I was posting, is actually really, really essential for security. It's very useful. And I think it's really a critical security function nowadays, especially if you do security testing on the software during continuous integration. Peer review is really, really great. We review 100% of our source code to make sure that there's no backdoors or anything that kind of stuff. When you're choosing new technology, choose slowly and carefully. It's great when you want to choose a new Docker orchestration framework, but you have to know, how do I configure this securely? How do I make sure it's not opening up an SSH port that I wasn't aware of? All that kind of stuff. You need to be considerate about everything that you're doing, making sure you're not just installing new stuff willy-nilly. And then you have to always ask yourself, what happens if this service is compromised? So like your Linchpin servers, like your continuous integration, or your Chef server, like what happens if your continuous integration server is compromised? Probably you're effed, but hopefully you can lower that to some kind of, okay, well if they compromise this, then this, but I have this other process in there, and you can lower that. Same thing with the Chef server. If they get knife access to the Chef server, how are you making sure that they're not backdooring everything? The artifact server, batching host, all that kind of stuff. Cloud-specific, really obvious ones like don't use the root account. Use roles, not access keys. Nowadays, you can say this EC2 instance is allowed to do this, not key-based, so you don't have any keys anymore. If you don't have any keys, they can't get lost. AWS Lambda and all this stuff have roles nowadays. It's a really, really great way to do it. Highly recommend using roles over access keys. Obviously, use 2FA, watch alert on your logs, and segment your network so that network access is actually restricted. If you're going to have network level off, it's really nice to actually segment your network, so not everything can talk to it. And then you can audit your your infrastructure access management regularly. Cloud logs, what to alert on, new access keys, new provision to users, roles, and groups. Obviously, if your attacker's adding new users, you want to know about it. New instances, this is kind of a problem though, because the way some companies work, they serve new instances every 5 minutes, and this would be a super terrible way to go. So you have to be kind of, you might have to tune down that alert to make it, maybe they don't have the right role set up with it or something like that. You have to be a little bit more specific. Suspicious console logins, this is like the normal SIM sort of bread and butter thing. Oh, you've never logged in from Russia before, that sort of thing. Disruption logging, like that one slide showed, you can disrupt logging in tons and tons of ways. Probably the easiest one is just if you're not getting as much logs as you normally are, you probably want to alert. And there's tons more to do on cloud logs. There's actually not a really great set of best practices yet, unfortunately, on what to alert on various cloud providers. So you kind of just have to do your own research at this point. But that's it. Any questions?
Yeah, so at one point you had the Jenkins file structure kind of down.
Yeah.
Did you just like download Jenkins and look through like where it was storing all of its sensitive data, or?
Yeah, so the question was, did I download Jenkins and figure out where it was storing its data? I used our Jenkins that we use at my company, and I just logged in and I was like, I know what these passwords are, where are they? And I just looked and I found they're in all these places. And then I found that the Jenkins user has read-write access to everything. And then I found that if you run tests, you're running as the Jenkins user and you have access to all of this stuff. And actually, I was going to write in this talk a simple little Java unit test that you could write that would automatically take control of the machine, but I ran out of time. It's like half implemented. But it uses that exact thing.
Thank you.
Any other questions? Cool, thank you very much.